All right. Where do minerals come from? No, that's a big question because they come from different areas. A lot of them come from cooling a molten material or, from inside or really quick outside with for igneous, extrusive and intrusive. Some of them even come with metamorphic. Some of them are dissolved in liquid and they evaporate in hot water. So we're going to go over a couple of these. The first one, remember, is cooling from molten material. We went over this with rocks. So if it's cooling really slow, especially intrusive igneous right here, those crystals, those mineral crystals are going to be really big. Okay. If they come out, they still have crystals. There's still minerals in them, but they're a lot smaller with extrusive. But we also have metamorphic rocks. They're changed with heat, pressure. Okay, so we have the metamorphic, which we already went over, but look at some of these. So again, extrusive, fast cooling, small crystals in there. Intrusive, big crystals you'll find. Hit and metamorphic can make really nice uh like gems and stuff like that. So by recrystallizing them. So again, the minerals calcite, quartz, and hematite can with heat and pressure they can melt together, and with heat and pressure together, they squish them together, and they can turn them into your garnets, which is January's birthstone. And we looked at this, and one of your samples was a garnet mica schist. So you could see all those little garnets were these three minerals combining with they just kind of melted together with the and being pressurized to get the garnets. Sedimentary rocks. We went through this before too. It's like minerals that are cemented together with and pressure and time. So they can get dissolved into liquid. And so those minerals can get dissolved into liquids. It could be water, or it could just be in the ocean water. And then they evaporate. The water evaporates out, and leaves the minerals behind, or it could be shot up into like super hot heated water, hydrothermal deposits where it goes in and to cracks and forms in like where that's where your chalcopyrite and your bornite will be. Halite is salt. That's what you have on your French fries. So that's an evaporite right here. It comes from the ocean, but that is a mineral. So again, hydrothermal deposits are pretty cool because a lot of times you get the metals into there. Some of the elements like native gold, copper, galena, which is our state mineral, sphalerite, cinnabar, and chalcopyrite. All those, a lot of those they get superheated by water, and then there's cracks. They find cracks into there, like a vein, and it gets shot into there, and then it cools into these really nice, yeah, veins that they'll go through. Uh, prospectors will look for these veins and follow the source. A lot of times, what they'll do it too is it'll come out of here by by weathering again. They'll break apart and go into water. And this is another example of um, huge hydrothermal deposits. I mean, in here they was water, superheated water, and a lot of those crystals to form. And when they broke into it, all the water had gone, and went away. So it's like these crystals with superheated water with a lot of minerals dissolved into them, just like if you're making Kool-Aid and sugar and stuff like that, you can stir it in and it disappears. Basically doesn't disappear, it just goes into the water. And then when the water evaporates, it leaves the crystals behind, huge ones. And that's what's happening. All these are hydrothermal deposits. And the coloring, what you get in here, is all done by bacteria, different forms of bacteria that uh, Archaebacteria, which is ancient bacteria that lives and eats all this stuff in here. But if you've ever been to, I'll put these links on here, but watch them. But these are all, if you've ever been to Yellowstone, these are hydrothermal deposits all over. There's mud pots, travertine. This is like limestone that's been dissolved and re-deposited at the Mammoth Hot Springs out there, and a little bit about Old Faithful and all that. And some other evaporites, remember, is like where ancient seas slowly evaporated. That's where you get your halite, your gypsum, which we use in drywall, and your calcite. So, and even though oh so famous, Ulexite, the TV rock, which we have. And what we're going to do on, well, I think on Friday, we're going to be making borax crystals for them. What we're going to do first is take the borax, dissolve in the hot water, get a hydrothermal deposit like that, and then make it into really, really hot. So, and then it'll evaporate. It'll become an evaporate. So it'll evaporate right out. So, and the water will go away, and then it'll slowly form these crystals onto that, or the crystals just won't have enough water to be able to stay in solution. So they evaporate out. So these would be evaporites too. We're gonna try them on different things like shells and rocks and uh, hopefully maybe a couple eggshells. And if I'll find around if I can get some other things like pine cones. They work great with, and and they do form and some really cool crystal patterns. All right, so that's just a little bit about how minerals are formed.